Good afternoon, boys and girls. This video is going to inform us of algebraic expressions as well as numerical expressions. All right, I'm going to go ahead and go over this example really quick. So far in this example, we should be identifying terms within an algebraic expression. What makes this algebraic in this case is actually the two variables. All right, I'm going to go ahead and identify my terms. Like we stated before, terms are separated by addition, subtraction, and will be division. So let's go ahead. I'm just showing this. Now we can easily see here, we have our two addition symbols. They're actually separating three terms. So we have a term as G, we have a term as 12, and we have a term as 9n. Now don't forget we said every variable has a coefficient of 1. So I'm just going to put that there so I remember that when I have to go to my coefficient when I identify all coefficients. All right, let's go ahead now and identify our coefficients. Again, a coefficient is a numerical value, a number that is a co-partner with a variable. So we have a partner right here, like we stated. We have 1 as a numerical value. We also have 9, that's a partner with the variable. So our coefficients have been identified. Now we have a constant. A constant is a number that remains by itself with no variable, no other operations along with it. In this case, we have 12 that's by itself. That is our constant. All right, this is how you identify terms within an algebraic expression. Again, terms are normally separated by operations such as addition, subtraction, and division. It's not multiplication because multiplication is necessary to have an algebraic expression. You will have necessarily. In this case, 9 times n. You don't separate 9 in the n. It's compatible as one term by itself. All right, I'm going to erase this and go into something else we've been also doing. Okay, the next thing we've been doing is now solving algebraic expressions. So let's say we have an expression m plus 7 divided by 2. Now, the only reason we will be able to solve this if we were given the value of m. So in this case, let's say m is going to equal 3. So how do you solve this? You input 3 for m. So you're renaming this expression 3 plus 7 divided by 2. Now you have to again consider, you have to follow PEMDAS. So we're going to do division before addition. So if we go ahead and divide this, we will actually get 3.5. Half of 7 is 3 5/10 plus 3. Now the reason I'm informing of this problem because remember what we talked about is where we made errors. Every whole number has an imaginary decimal that is necessarily not written, but we know that 3 is also associated as 3.0. So if we now can go ahead and add this, we have our decimals lined up. We would get 5, 6, and 5/10 as our final outcome. All right, that is when you're solving an algebraic expression and a variable has a given numerical value, a number. You just input and then you rename it with the input and then you evaluate. This means to solve it. And make sure again you're following PEMDAS. All right, next scenario. Next scenario is writing algebraic expressions. So here's an example of one. 5 times a number d. Okay, what we say, we need to identify our actual information that is going to inform us that we necessarily are going to be doing an operation. In this case, we have the word times, and this means multiplication. So we're going to clearly write our expression to make sure it matches this actual statement. So 5 times multiplication, a number d. So 5 times d would represent this. Is 5 times a number d? Yes. Why is it a number d? Because we now, at this point, we don't know the value of d. D is not given, so therefore it is a number, but it's not just stated right now. All right, another example I will go over if you have a problem such as a chart, let's go over something like that because we had some questions on that today. Let's say we have x, and underneath x we have 4, 8, 12. And then we have an expression as 3x plus 3. So when you see this like this, this is clearly stating that here's an expression here, 3x plus 3, and these are all inputs. So if you were to input these three values, 4 and here, and evaluate this expression with 4 replacing x, what would be your outcome? I'm going to go ahead and do that for this one. So we have 3. I'm now going to replace x with the input of 4. I'm going to rewrite this, just inputting 4. Now, we need to solve this. Well, 3 times 4 is 12. 12 plus 3 is 15. Now, do the exact same thing. You have the inputs over here. You input them into the expression, and then you evaluate. So my next input is 3 times 8. Again, a number next to a numerical value, a number next to a variable, it explains that we should necessarily multiply. That's the operation we should be doing, multiplication. Now we're going to keep our plus 3 here. 3 times 8 is 24. 24 plus 3 is 27. Now we have one more input to input into this actual expression. So 3 times 12 plus 3. 3 times 12 is 36. 36 plus 3 is 39. Okay, so when you happen to see this possibly on your test, you will see this on your test or your possible quiz, this is what you need to do and go about in solving this. This is the original expression that you're given. The x values, these are all inputs. An input is what you are going to input in for x. So if x were to equal 4, what would your outcome be? There it is. If x were to equal 8, what would your outcome be if you put it in for x? There you go. What would your outcome be if x in this case were 12? You insert 12 into x's position, then you go ahead and you evaluate this expression. One more thing I want to just go over really quick. Let's say we had m times n times n times n. We need to write this expression in an algebraic expression. Let's just go ahead and put, well, you count your m's. How many m's do we have? 2. So we'd have 2 squared. We're using exponents to write this algebraic expression. We're combining, we're condensing. It's almost like simplifying. We're simplifying this expression. Now, n's, we have 1, 2, 3. So now we have n to the third power. So we have now condensed or simplified this expression using exponents. All right, again, if you have any questions, go ahead and leave the question in the commenting area, or you can just, when we get to class, inform me of your question and I will go over it with you. All right, I hope you guys have a great night. See you later. Bye.